The paradox is the only thing that brings truth to light. Sometimes a question isn't meant to be answered. It exists to shake the ground beneath your certainty, to pull at the edges of what you think reality is. These aren't riddles or tricks of language. They're the raw collisions between logic and the universe. And somehow, they've survived every attempt to resolve them. This is not just a list of curiosities. It's a journey into the deepest tensions in science. The places where our best ideas stop working. You'll encounter time loops that close without ever opening. Civilizations that should be everywhere, yet remain unseen. And moments when observing something actually changes what it is. You'll meet cats that are both alive and dead. Billiard balls that collide with themselves, and black holes that may be erasing history. Each concept begins with something simple. But the moment you follow it to its logical end, something breaks. And that's where it gets interesting. If you're someone who finds beauty in not having all the answers, who doesn't mind staring into the unknown a little too long, then you're in the right place. The universe isn't neat. It's layered, unstable, occasionally impossible, and maybe, just maybe, that's the point. Space looks calm, but it hides a question that's anything but peaceful. We live in a galaxy with hundreds of billions of stars, most of them older than our sun. We now know that many of those stars have planets, and a surprising number of those planets might have conditions similar to Earth, warm enough for water, stable enough for life, old enough for something intelligent to have emerged. So, where is everyone? We've been listening carefully, patiently. Giant radio telescopes have scanned the sky for decades, hoping to catch a whisper, a signal, anything artificial. But what we've found is silence. Deep, constant silence, as if we're shouting across a canyon and hearing nothing back. Not because no one's there, but because maybe something else is going on. Statistically, we shouldn't be alone. The numbers suggest that intelligent life should have appeared many times, in many places, even with cautious assumptions. There should be hundreds, maybe thousands, of civilizations in our galaxy alone. And yet, not a single verified signal. Not a single undeniable trace. Just stars. Just distance. This contradiction has a name, but it doesn't need one to be felt. It's the kind of question that settles in late at night, when you're staring out a window and realizing how much sky is really out there. It challenges the belief that life leads naturally to technology, that intelligence leads to communication, that progress is guaranteed. Maybe civilizations rise and fall too quickly to be noticed. Maybe they destroy themselves before they ever get the chance to reach beyond their home. Or maybe they're out there right now, watching quietly, choosing not to be seen. There's another possibility, one that sits heavier than the rest. Maybe we really are the first. That idea changes everything. It makes humanity something fragile, something rare. It means we're not just searching for others. We're carrying something that might not exist anywhere else. A chance to speak when no one has spoken. A responsibility not to vanish before we're heard. If that thought makes the stars feel colder, or the silence feel heavier, you're not alone. When the sky remains quiet for this long, it stops feeling empty. It starts to feel deliberate. Not long ago, Earth was the only known planet with the right ingredients for life. A fragile blue dot orbiting a modest star, unique and alone. But that illusion shattered. Thanks to modern telescopes and sky surveys, we now know our galaxy is overflowing with planets, hundreds of billions of them. And among them, Earth-like worlds are not rare. They're common. Data from the Kepler mission confirmed it across the Milky Way. There may be over 300 million rocky planets orbiting sun-like stars in the so-called habitable zone. Not one or two, hundreds of millions. Worlds with oceans, worlds with sunlight, worlds with time. Even if a tiny fraction of those ever gave rise to biology, and an even smaller number to consciousness, we should be seeing signs. Flickers of communication, traces of machinery, artifacts that say someone else passed through here. But the sky remains quiet. This isn't a poetic silence. It's a sharp contradiction. The kind of math that breaks your sense of scale. Because space isn't just big, it's old. Some of these stars are billions of years older than our sun. That's more than enough time for life to evolve, build civilizations, and reach across the stars. If it ever happened even once, in even one place. Why do we see nothing? It starts to feel like walking into a vast cathedral and realizing you're the only one breathing. The air should be full of voices, echoes, footsteps. Instead, it's empty. And the more you learn about how full the universe should be, the more unnatural that emptiness feels. There are theories, of course. Maybe intelligent life doesn't last long. Maybe it hides. Maybe it's spread out so thin that we'll never find each other. But every explanation comes with its own problem. Every answer leads to another question. Why does it seem like we arrived late to a party that never happened? If there are millions of worlds out there with life, why is ours the only one that feels watched? Some problems don't come from a lack of information, but from too much logic, the kind that leads you straight into a wall. That's what happened in 1961, when an astronomer tried to turn a mystery into a formula. The equation wasn't meant to solve anything, just to lay out the variables. How many stars form each year? How many have planets? How many of those planets can support life of those? How many actually develop it? How many forms of life evolve intelligence? How many intelligent beings build technology that can be detected across the stars? And how long do those civilizations survive? Multiply it all together, and you get an estimate, a number. Something that tells you how many alien civilizations should be broadcasting through our galaxy right now. And here's the part that never quite fits. No matter how conservative the inputs, the answer usually isn't zero. The Drake equation suggests we should be surrounded. That radio waves should be washing over us. Whispers in every direction. Signals coded in pulses. Patterns. Artificial echoes. But again, silence. So, we go back to the formula. Try to make sense of it. Maybe we were too generous. Maybe life doesn't evolve easily. Maybe intelligent life is rare. Maybe technological life is rare. Or maybe the last variable, the lifespan of a civilization, is where everything collapses. How long do we last? There are two ways to explain the silence. One is terrifying, the other is worse. The first imagines the galaxy not as a void, but as a place full of watchers. Civilizations vast and intelligent, scattered across the stars, but each one hiding, listening, waiting, and terrified to be found. Not because they're paranoid, but because they've learned something we haven't. This idea paints the universe as a dark forest. Every species is a hunter, every planet a hiding place. The moment you reveal yourself a message, a light, a signature, you become a target. Because in a place where you don't know who or what is out there, The safest strategy is silence. And when something makes a sound, it disappears. That would explain why we haven't heard anything. Maybe the others are out there, but they're not speaking. They're watching us, wondering if we're smart enough to stay quiet or foolish enough to shout into the dark. It's a grim theory, but it matches the facts. No signals, no contact. Just an endless field of stars, all seemingly mute. Then there's the other possibility that there's nothing out there at all, not because it's hiding, not because it's dangerous, but because we're alone. This is the empty ocean, vast, silent, not because it's being quiet, but because there's simply no one else in the water. We may be the first to sail this far, or the only ones who ever learned to build a boat. Both ideas explain the silence. Both are deeply unsettling, because if the galaxy is full of eyes, we're being watched, and if it's empty, we're it. The lone witness, the last hope, the species that, if it fails, leaves nothing behind, so we go on listening. And we wonder what kind of galaxy we live in, a forest full of threats, or a sea too big for voices to carry. And maybe the scariest thing isn't that the others are silent. It's that they were never there to begin with. We used to think we were at the center of everything. Then we learned the Earth orbited the sun, that the sun was just one of billions of stars, that our galaxy was one of trillions. And still, somehow, we assumed we couldn't be alone. But the silence is starting to change that. It's not just that we haven't found intelligent life. It's that we keep discovering more reasons why we should have. More habitable planets, more time, more tools, more chances. And yet, the universe stays quiet. It's not whispering. It's not murmuring. It's absolutely, overwhelmingly mute. There's a strange emotion that comes with that. Not fear, exactly, and not wonder, either. It's a kind of cosmic loneliness, a sense that the vastness out there is real, and no one else is watching it with us. But maybe silence doesn't mean emptiness. Maybe it means fragility. If life is rare, we might be holding something irreplaceable. If intelligence doesn't last, we may be a flicker in the dark, one that could go out just as easily as it appeared. And if we are the first, then we're more than observers. We're the experiment, the first voice in the void. And that means we don't just get to ask where the others are. We have to ask what kind of story we want to leave behind, what kind of legacy we're building, or failing to build, for the next travelers who might someday find what we've left. Maybe that's what makes this silence so heavy. It reflects everything back at us. We don't hear aliens because maybe we're supposed to hear ourselves. A warning, a chance, a responsibility. In a galaxy full of noise, silence is the one sound you don't expect. And sometimes, silence is the loudest answer of all. Time feels like the most stable thing we know. It ticks forward, never back. Seconds pass, days end. A cause leads to an effect. And yet, there's a strange fracture hiding under this rhythm. A possibility that time may not just move, it may circle. That's where the next problem begins. Imagine a loop, not a metaphor, not poetry, a literal loop in time. You take something from the future, bring it to the past, and that thing ends up becoming the very reason it exists. There's no beginning, no creation, just an endless cycle with no origin point. A story that keeps telling itself. This is the foundation of one of the most unnerving contradictions in physics. The kind that doesn't just challenge what's possible, but what existence even means. Picture this: you walk into a bookstore and buy a copy of Hamlet. Later, you build a time machine, just for fun. You go back in time, all the way to Shakespeare's London, and hand him the book. He reads it, likes it, puts his name on it. And centuries later, that exact copy ends up in the same bookstore, the one you walked into. Who wrote it? It didn't come from nowhere. But it didn't come from anywhere either. This kind of loop has a name. But names don't make it easier to digest. It's a cycle where the cause is the effect, and the effect is the cause. A piece of information or an object that exists in time, but not because it was created, just because the loop never breaks. And while this sounds like a writer's thought experiment, it's something general relativity doesn't rule out. In fact, Einstein's equations allow for closed time-like curves, paths through space-time that circle back on themselves. Under certain conditions, you could travel to your own past and bring something with you. It's not just strange, it's destabilizing. Because if time can do that, if loops like this are real, then nothing is truly original. Not ideas, not inventions, not even you. If the rules of time can circle around like this, then reality is less like a straight road and more like a spiral staircase. You keep climbing, but every so often, you pass the same point again. And this time, you're the one holding the book. The deeper we go, the more time starts to fold in on itself. And maybe what we think of as the beginning is just the middle of the loop. You hand the book to Shakespeare. He reads it, memorizes it, and publishes it as his own. Hamlet becomes a masterpiece, passed through generations, taught in schools, printed, performed, worshipped. Centuries later, you walk into a bookstore and pick up the same copy. You take it back in time. The loop closes. No one wrote it. This is the heart of the problem, not just an object with no origin, but information that sustains itself through time without ever being created. There was no flash of inspiration, no author with a quill, no mind behind the words. The story simply exists because it always has, because it never didn't. And this breaks something fundamental. We build our world on the assumption that everything has a source. Thoughts come from minds. Machines come from inventors. Music comes from composers. But in this loop, the source vanishes. And yet, the thing remains. It makes you wonder what else could exist this way. A scientific formula, a technological blueprint, a piece of knowledge that appears in one mind and is passed into the past, only to return in the future, unchanged. A perfect circle, like a song with no composer, playing endlessly on repeat. Physics doesn't dismiss this. Einstein's theory of relativity doesn't forbid time loops. In fact, certain solutions, especially involving extreme gravity or hypothetical constructs like wormholes, allow for scenarios where the past and future intersect. And that opens the door to self-created objects, self-initiated events, cause and effect dissolving into one continuous ribbon. It also opens something darker. What if we're part of such a loop? What if an idea, a piece of our own civilization, a technology, a belief, didn't originate here, or now, or from us? What if we're just carrying the torch from a future that already knew what we would do if time allows loops like this? Then invention becomes memory, and history becomes rehearsal. Think of time as paper flat, linear, clean. You can draw a line from the past to the present and extend it toward the future, smooth and sensible. But what if that paper folds? What if two points that should be years apart suddenly touch? That's what happens in a closed time loop. An object doesn't just move through time, it escapes the timeline entirely, bends it, and connects the end to the beginning. Like a crease in the universe, a fold that makes yesterday and tomorrow neighbors. It sounds abstract, but this is what some solutions to Einstein's equations suggest is possible. Near rotating black holes, under certain conditions, or through hypothetical wormholes, time doesn't have to flow in one direction. It can circle. It can collapse in on itself. It can, in theory, be folded like origami. And when that happens, strange things start to make sense. You place a violin into a time machine and send it backward. A composer in the past discovers it, creates music with it, and that music becomes famous. The violin is preserved, passed through generations, until one day, you find it and send it back again. There was no original craftsman, no moment of creation, just a loop, a shape folded perfectly in on itself. These loops are self-consistent. They don't break the timeline, they preserve it. As long as the events don't contradict themselves, the loop can continue forever. Nothing needs to be explained, because the explanation is the loop itself. But this elegance hides something deeply strange. Because if time can fold like this, then what is memory? What is invention? What is the difference between discovering something and being handed it from a future you haven't lived yet? Maybe this isn't fiction. Maybe something you believe. Something you've read or thought or built isn't original at all. Maybe you're just one fold in the paper, one crease on the map, and the idea was already traveling back to you. It changes how we see progress. Maybe we don't build ideas, we receive them. Maybe we're not inventors, we're couriers. And if time can fold like this, how many folds are we standing on without even noticing? Some systems can break with too much information. Stand too close to a speaker while holding a microphone, and you'll hear it, that rising screech, the howl of a loop forming. Sound enters, gets amplified, re-enters, and builds until the system collapses under its own echo. Now, imagine reality doing something similar. In certain models of time, events can form feedback loops, not because something is repeated, but because an effect becomes its own cause. The future reaches back, feeds into the past, and together, they generate the present. It's not a story told in order, it's a circuit. Think of a physicist who receives the final form of a revolutionary equation from her future self. She studies it, understands it, publishes it, and eventually becomes the one who sends it back. The knowledge exists. It's useful. But where did it come from? The loop feeds itself. No contradictions, no inconsistencies, just a clean, recursive chain, a stable paradox. And this kind of logic is being taken seriously, especially in the world of quantum mechanics. Some researchers believe information in our universe may not always flow in a straight line, that the past, present, and future can become entangled, with effects determined by future measurements, systems that only become what they are after they're observed, events that only occur if the timeline stays intact. It's called post-selection, and it breaks everything we thought we knew about causality. These loops aren't accidents. They're constraints. Nature, some believe, only allows realities that fit together perfectly. Inconsistent stories are discarded. Universes that don't make logical sense, where paradoxes explode, never stabilize. Only self-consistent histories survive. That means reality might be editing itself in real time. You're not just experiencing the world forward, You're part of a loop that constantly tests whether your choices, your memories, even your thoughts, fit. And if they don't, the loop never forms. That version of you never exists. What emerges is something far stranger than linear time, a feedback-driven cosmos. Always echoing, always checking, always curving back on itself. No beginnings, no final cause. Just an endless, self-sustaining pattern. If that idea turned the arrow of time into a circle in your mind, perhaps what we call reality may be less like a story and more like a closed equation, trying to solve itself. And if the universe is listening to itself, maybe that's why we're here to complete the loop. We think of the past as the foundation, the unmoving bedrock beneath everything. It came first. It caused what's happening now. But what if that's not entirely true? What if the past isn't just the beginning, but the outcome? This isn't imagination. It's a real, unsettling consequence of physics. In some interpretations of quantum mechanics, and even in the way we model certain space-time geometries. The present isn't just shaped by the past, it's also constrained by what the future has to become. Take a quantum system, a particle that could exist in many states. It's fuzzy, undefined, until you measure it. But here's the twist in certain experiments. The outcome seems to depend not only on how you set things up, but on what you decide to do after the system evolves. The future choice affects the past behavior. This backward influence isn't just a metaphor, it's built into the equations. It's as if the particle was waiting, not just to be observed, but to see what kind of future it would end up in, and shaped its history to match. And it doesn't stop with quantum particles. Some physicists propose that even macroscopic systems, our bodies, our choices, our history may exist within a larger consistency loop. That the past you remember is only one of many possible ones, the one that best fits the outcome that must exist. In this view, time isn't a single river flowing forward. It's more like a web. The present is a node, held in place by threads pulling from both directions. Tug too hard on one side, and the whole thing vibrates. The future doesn't just emerge from the past, it molds the path behind it. You can see why this idea doesn't sit comfortably. It pushes us into a world where free will, memory, and even identity are all conditional, where your past wasn't fixed until the future called it into focus. It also means that the universe might not be moving towards something. It might be settling into something, collapsing into a shape where every part agrees with every other part. Cause and effect dissolve into structure. If the past is only real because the future needs it, then who, exactly, are we now? The most mysterious part of time might not be where it goes, but how it decides what already happened. And maybe what feels like memory is just the echo of what the future couldn't live without. You build the machine, step inside, type the year. You're going back, not to witness, not to observe, but to act. And the target isn't a king or a tyrant. It's your grandfather, not out of revenge, just to test the rules. Because if you succeed, if your grandfather dies before your parent is born, then you were never born either. And if you were never born, then you never stepped into the machine. And if you never travel back, then he lives, and you exist, and then you go back, and the knife is in your hand again. This is more than a loop. It's a contradiction folded into reality itself. An action that erases the very possibility of the action. A wound that heals and reopens in the same breath. It's known as the grandfather paradox. But it doesn't just live in fiction. It's one of the biggest threats to the idea that time travel could ever be real. Because if the past can be changed in a way that unravels the present, then the timeline isn't stable. It's fragile, glitch-prone, self-erasing. Physics doesn't like that. So, several possibilities emerge. One is brutal in its simplicity: time travel is impossible. Not because it violates logic, but because it creates an unstable system, like a program stuck in an infinite crash reboot cycle. Reality would just fail to load. But there's another idea, something more subtle. Some theories suggest that time protects itself, that no matter how hard you try, the timeline bends around your actions. The gun misfires. You get second thoughts. A stranger intervenes. Something stops you, every time. Not because the universe is watching, but because consistency is its only rule. You can try to change the past, but you'll only ever do what already happened. And then there's the most mind-bending possibility of all. The moment you interfere, the universe splits. You don't change your past. You create a new one. A branching world. A new timeline. A fork that moves forward without you. You're stuck in it now. A ghost from a different history. Your original world moves on without you. Unchanged, unreachable. And the more you think about it, the more the blade in your hand starts to feel like something else entirely, a test of reality's willingness to let you choose. Some ideas don't end in mystery, they end in contradiction. The kind that doesn't just confuse, it unravels. That's what happens when you follow the grandfather problem to its final breath. Because no matter how you try to twist the outcome, it doesn't hold. You travel back. You stop the birth that leads to your existence. But if you succeed, you erase the one who took the trip. The action negates itself. A perfect loop of cancellation. A story that deletes its author mid-sentence. This is the nightmare of causality. And unlike poetic paradoxes or theoretical folds, this one doesn't quietly loop. It explodes. Physics hates it. Logic rejects it. Yet the possibility hangs in the air, because time, in all its elegance, might allow motion backward. What it doesn't seem to allow is contradiction. That's why many scientists propose a kind of narrative repair mechanism. Some call it self-consistency, others call it cosmic censorship. But the idea is the same: events may wrap and loop, but they can't break each other. You can go back, but only to play your part in the story that already exists. Try to step off script, and the universe pulls you back. You meet your grandfather. You raise your hand. But something stops you. A coincidence, a twist, a failure. It doesn't even have to be dramatic. It just has to make the contradiction disappear. You don't get to change the past. You become part of it. This makes time travel less like control and more like choreography. You can move freely, but only along the lines already drawn. You're not breaking the story. You're fulfilling it. But if that's true, if paradoxes are simply impossible, then free will becomes paper thin. Your choices may only exist if they've already fit into some unbroken loop. There's no risk of destroying time, because time already knows what you're going to do. And yet, the contradiction lingers. What if there's no repair, no resistance? Just a tear. One action too bold, one moment that logic can't wrap around. Then what does time shatter? Does a new branch grow, or does everything just stop? Somewhere buried in these loops and splits, there might be a deeper pattern. And maybe the reason the past feels so stable is because we haven't broken it yet. There's a strange idea hiding behind every paradox that the universe has standards, that it won't tolerate contradictions, that somewhere beneath the noise and chaos, there's an editor, quietly deleting impossible stories before they spread. Imagine time not as a straight recording of events, but as a self-writing manuscript. The rules aren't just about gravity and light. They're about narrative stability. And when something threatens to rip the story apart, a paradox, a contradiction, a grandfather dying too early, the timeline rewrites itself. Not with magic, but with constraint. In physics, this idea shows up as the Novikov self-consistency principle. The concept that any event occurring in a time loop must be self-consistent. In other words, time may allow loops, but never contradictions. You can travel into the past, you can interact, but you can't change the outcome. You can only fulfill it. It's not that you can't act freely. It's that your freedom is already written into the past. You're trying to change. It sounds like fate. It feels like being trapped inside a script. A character who believes he's improvising, but is actually walking the exact same lines every time. This principle has eerie implications. It suggests the past is not just resistant to change, it's immune. Try to break it, and you'll find the gun jams, or you miss, or you get stopped. Not because of magic, but because of logic. Because paradoxes can't exist, and the universe has already accounted for your failure. But what if, instead of editing the timeline to avoid paradox, the universe allows a split? This is where things fracture. Some models propose that a contradiction doesn't get fixed. It gets isolated. You create a new timeline, a parallel stream of reality where your impossible action plays out. The original timeline remains untouched, but you're no longer in it. You're somewhere new, alone, in a version of history that was never supposed to happen, and you can never go back. So either the timeline bends around your choices, or it breaks away from them. In both cases, something is lost, the dream of absolute freedom. The deeper we dive, the more time starts to feel alive, not flowing, but thinking. And if the universe is really editing itself to avoid paradox, what happens when even the editor fails? You take a step, simple, meaningless. But what if that step, or the hesitation before it, splits the universe in two? One version of you keeps walking, the other stops. Two timelines, now branching forever. Not just a metaphor, not a narrative device, but an actual structure of the universe. Sprawling, infinite, and made from decisions you didn't know mattered. This is the many worlds interpretation of quantum mechanics. And it doesn't just suggest alternate realities, it demands them. At the quantum level, particles behave like possibilities. A photon doesn't go left or right, it goes both, until observed. A particle isn't in one place, it's smeared across outcomes. But when you measure it, you only see one version, one reality, one result. So what happens to the others? Many worlds says they happen too. Every outcome is real. Every possibility is realized. But not here. Somewhere else. And if this applies to particles, it applies to you. To every moment you faced a choice, big or small. Every word you said or swallowed. Every person you met or missed. Somewhere out there, you are all of them. It's a haunting kind of freedom. Because now your life isn't a straight line. It's a tree, endlessly branching. Your regrets are real somewhere. So are your triumphs. So are your losses. So is the you that never came to be. And when you imagine going back in time to change something, to fix a mistake, save someone, undo a decision, you're not overwriting the timeline, you're creating a fork. A new path splits off, and you're walking into it. The past remains untouched, but you can never return. This solves the problem of paradox. You can kill your grandfather in that timeline, but your original self, the one who took the trip, still came from a world where he survived. The contradiction dissolves into a detour, but now the stakes change, because every action has consequence, not just here, but everywhere. Every choice echoes into its own universe. And if that's true, then you've already created countless realities with thoughts you barely noticed, with moments you barely remember. The choices don't stop. The tree keeps growing. And somewhere, right now, another you is wondering if you made the better choice. Imagine waking up and feeling like something is slightly off. The room is the same. Your memories are intact. But you can't shake the feeling that a decision, maybe years ago, maybe yesterday, went differently than it should have. That sensation, that eerie dislocation, it might be nothing, or it might be the echo of a nearby reality, a version of you that chose differently and is now living a life you'll never see. In the many worlds view of reality, you are not a single thread of consciousness. You are a node, one observer among infinite versions of yourself, each riding a different branch of the quantum tree. And the strange thing is, the you that's reading this right now might not be the original, because once the universe splits, all branches are equally real. No timeline is more true than the others. They all unfold with the same weight. The only difference is, this is the version you remember. But memory is not immune. In some interpretations, even your awareness may shift, subtly, slightly, as reality forks. You don't notice the change. You feel continuity, perhaps deep inside. Something in you recognizes that another you made another move. And now they're watching from a different branch. Quantum computers already work with these ideas, running calculations across superposed states, using entanglement to process multiple outcomes simultaneously. It's not magic, it's physics. And it suggests the mind itself might not be a closed loop, but a spread, like a song playing across harmonics you'll never hear. And maybe that's what déjà vu is. Maybe that's what dreams are. Maybe we are constantly brushing up against the edges of the choices we didn't make. If that thought landed somewhere deep in your chest, like a memory you've never had, like a version of yourself blinking through the dark, they're probably not the only version of you watching this right now. Because you didn't just pick a path, you became one. Take a box, seal it tight. Inside, place a cat, a small radioactive atom, a vial of poison, and a trigger mechanism. If the atom decays, the poison is released. The cat dies. If it doesn't decay, the cat lives. You don't check. You don't peek. You wait. Now, here's the question before you open the box. Is the cat alive or dead? Logic screams one or the other, but quantum mechanics disagrees. In this setup, the atom is in a superposition decayed and not decayed. And because the mechanism depends on that atom, the cat is now entangled with it. It, too, exists in a strange limbo, both alive and dead, until you look. This is the heart of one of the most infamous thought experiments in physics, not because it's gruesome, but because it reveals something deeply unsettling. That observation doesn't just reveal reality, it decides it. Before you observe, the cat is a quantum blur of both outcomes, alive and dead. Two paths simultaneously real. But the moment you look, one becomes your reality, the other fades. But where does it go? In the many worlds view, it doesn't disappear. The moment you open the box, the universe splits. In one branch, you see a living cat. In the other, you find a corpse. Both outcomes are preserved. Not just in theory, but in structure. Somewhere, there is a version of you grieving. Somewhere else, there's relief. And you, the observer, are the dividing line. It's not just the cat in the box. It's every moment of uncertainty, every coin flip, every crossroads, every time you waited for the test result, the phone call, the yes or no. Each one was a branching point, a box you didn't open until it was already too late to undo. And in this world, you only get to see one outcome, but the others, they're still unfolding. This isn't just a physics problem, it's a mirror. And maybe the scariest part isn't whether the cat is alive or dead. It's knowing that somewhere, it's both. A cat in a box, a particle in a cloud, a decision unmade. In quantum mechanics, these aren't just moments of waiting, they're moments of suspension, where outcomes don't just sit side by side. They exist that way, at least until someone looks. And here's the twist that still rattles physicists: the moment of observation doesn't just reveal what's there, it finalizes it, locks it in, collapses the wave of possibilities into a single, solid fact. But what if the thing that causes the collapse is you? Not your eyes, not the device. Consciousness. It's one of the most disturbing ideas buried in the foundations of physics, that the observer isn't passive. You're not just watching the universe unfold, you're a participant, a trigger. The act of witnessing decides what was real all along. Some call this the measurement problem, but calling it a problem doesn't make it go away. The equations are clear before measurement. Particles don't have definite positions, they exist in overlapping states. Only when something, observes, does the system snap into a single, classical outcome. It's like reality waits for you. Not politely, not patiently, but fundamentally. This raises a question most physicists try not to ask too loudly. What is observation? Is it just data, a sensor, or is it the presence of awareness? If the answer includes consciousness, then suddenly you, the one asking the question, become the central mechanism. You're not a background character in the universe, you're part of what builds it, collapses it, shapes it. And if you collapse the wave function, what are you doing every time you choose? Maybe you're not choosing at all. Maybe you're selecting a version of reality that already existed, and the others fall away behind you, like echoes you'll never hear. If that makes your own thoughts feel like instruments, like tools of creation rather than observation, like maybe the very act of wondering carves something into the cosmos, then maybe that's what the cat was waiting for all along. Not science, not fate, just you. Take two particles, create them together in the same moment, under the same conditions, then separate them. One goes left, one goes right. Light years apart, entire galaxies could fit between them. And yet, measure one, and the other reacts instantly. It's not just fast, it's faster than light. Too fast for any signal to pass between them. Too fast for any message to warn the second about what just happened to the first. This is entanglement. And it might be the strangest thing quantum mechanics has ever shown us, because once two particles are entangled, they behave like one system, no matter how far apart they are. Their properties aren't just correlated, they're connected. Change one, and the other's state is instantly determined. Einstein hated it. He called it spooky action at a distance. He believed there must be something hidden, some variable we couldn't see, that explained this weird synchronicity. But every experiment said otherwise. Bell's theorem, and the countless tests that followed, crushed the dream of hidden variables. The universe really is non-local. Entangled particles behave as if distance doesn't exist, as if information doesn't need to travel because it was never separate to begin with. Now, think about that. Two particles that used to be one, still behaving like one, across space, across time. And here's where it gets uncomfortable. Because if particles can stay linked across the void, why not systems? Why not minds? What if every interaction, every touch, every moment of shared creation leaves behind a kind of entanglement, invisible but real? What if entanglement is the rule, not the exception? Then space itself begins to feel thinner, less like a barrier, more like a surface stretched between moments that never really broke apart. You are not alone. You are never unconnected. You are part of a web older than light. And if that changed how you feel about distance, about time, about separation, about what it means to be apart, then physics just showed us something we can't explain. And maybe what binds the universe isn't force or mass or charge, but memory. Let's say you throw a book into a fire. The pages blacken, curl, and vanish into smoke. But the words, the meaning, the information isn't truly lost. Not completely, in principle. If you knew every molecule of ash and air, if you could rewind every photon, you could recover it. You could reconstruct what was there. That's how physics works. Energy transforms. Information persists. Nothing is truly erased. Except, what if that's not always true? Now, picture a black hole. You drop something in a book, a spaceship, a person. The event horizon swallows it. No signal escapes. No trace returns. From the outside, all you ever see is the black hole growing slightly more massive, slightly more distorted. And here's the terrifying part, according to the classical view. The information about what you dropped in its arrangement, its story, its structure is gone. Not just unreachable, destroyed. This is the black hole information paradox. Because according to quantum theory, information must be preserved. It's the bedrock of how everything works, from the tiniest particle to the edge of the cosmos. But black holes, under general relativity, don't care. They take it, crush it, and hide it behind an invisible boundary from which nothing escapes. So which law breaks? Decades of argument followed. Some said the information is lost forever. Others said it must leak back out, encoded somehow in the radiation that black holes emit as they slowly evaporate. But no one could prove it. It's not just a question of astrophysics. It's a question of what can be known. If information can be destroyed, then so can meaning. So can memory. So can you. What if the universe has places where the rules vanish? Where knowledge enters and nothing, not even the ghost of it, survives? Maybe the black hole isn't just an object. Maybe it's a boundary. The edge of reality's ability to keep its own story straight. At the edge of a black hole, even truth can slip away. And maybe the most terrifying thing isn't falling into the void. but knowing that no one will ever know you were there. A black hole evaporates, slowly, relentlessly, over eons. It radiates away mass, a whisper of heat escaping from its edges. This is Hawking radiation, predicted decades ago, still unconfirmed, still unnerving. Because if it's true, then black holes don't last forever. They fade, until one day, they vanish. Gone, without a sound, no explosion, no trace, just a slight ripple in space-time. And then, nothing. And here's the deepest fear: if everything that fell into it, light, matter, thought, structure, is gone too, then the universe just lost something it can never get back. A page was torn from the cosmic book and burned. This isn't just about stars and gravity. It's about the foundation of physics. Unitarity. The idea that the information about a system's past is never destroyed, just transformed. The equations demand it, but the black hole seems to ignore it. Its evaporation looks clean, sterile, as if the universe itself is slowly forgetting something. And if enough of these vanish, what does the cosmos become? A place of empty silence. No structure, no record, no imprint of what once was, not even a shadow. The black hole information paradox was never just a question of physics. It's a question of identity. If the universe can lose information, can it lose us? Some theories try to solve this, that information is stored on the event horizon like a hologram, that it's smeared into radiation as the black hole evaporates, that it's hidden in correlations too subtle to detect. But we don't know. We still don't know. And maybe we never will. Because this is where science meets something darker, the idea that reality itself may not remember everything. That some stories, entire galaxies, entire lives, might fall into silence with no echo, no footprint, no way back. It makes the question bigger than survival. It becomes legacy. What do we leave behind if even the universe forgets? Some paradoxes aren't about confusion. They're about grief. And maybe the universe won't end in fire or ice, but in forgetting. Somewhere along the line, we started believing that anything could be known, that the universe, no matter how strange or vast, would eventually give up its secrets, that science, given enough time and tools, would explain it all. But what if that belief is just another illusion? What if there are places in reality we were never meant to reach? Not because they're hidden, but because they can't be known. Every paradox we've explored: time loops, vanishing information, superposition collapse hints at one brutal truth. Our minds were shaped by evolution, by survival, by a need to make sense of the ordinary, not the infinite. We're built to find patterns in bird songs and faces, not to parse 12-dimensional Hilbert spaces, not to intuit a universe where one event creates two timelines or where causality flows both ways. So we reach, we model, we simulate, but we're still watching shadows on the cave wall. Reality remains behind the curtain, and every time we peek, the light burns our eyes. What if the reason these contradictions persist, these loops and disappearances and impossible decisions, is because we're trying to force logic onto something that was never logical to begin with? The universe may not be broken. Our perception might be. There's something unsettling in that thought. Not just that we don't know, but that we might never be able to know. That our questions hit a wall, not of science, but of mind. That reality is too large, too recursive, too alien for brains wired for beginnings, middles, and ends. And yet, we ask anyway. Maybe that's the most human thing about us? Not intelligence, not memory, but the willingness to stare into a problem that refuses to resolve and keep staring. If your mind feels tired, but strangely awake, like it just ran into something too big to hold, this journey isn't about answers. It's about staring at the boundary between understanding and mystery, and the haunting possibility that beyond that boundary, there's only silence. What if we're not late? What if we're early? We often imagine ourselves as the newcomers in a galaxy already full of ancient civilizations. The silence then becomes eerie, suspicious, a mystery to decode. But what if there's no one else to decode it? Not because they're hiding, but because they were never here. In that version of the universe, we aren't just curious. We're alone, not by accident, but by chronology. Ours might be the first spark of self-awareness to ever rise from the dust. The first time the cosmos has looked inward and asked, "What am I?" That idea changes everything. Suddenly, we're not explorers. We're origin points. The first voice in an empty cathedral. The first pattern of thought. The first hands to build machines that dream. And with that position comes weight. A terrifying kind of responsibility. Because if we are the first, then what we do matters more than we can possibly understand. We're shaping not just our future, but the blueprint for what intelligence can be. Our survival or our failure becomes the prologue to all consciousness that may follow, or the final chapter of something that never had a sequel. And the silence, it stops being ominous. It becomes sacred. Not a warning, but an invitation. A vast, untouched space, waiting for its first story. But what kind of story will it be? A species that builds until it forgets why it began, or one that learns, adapts, reaches, and speaks? We may be standing at the beginning of something that has never happened before. And the first mind to awaken in the void has the power to shape everything that comes after. All of this, the science, the paradoxes, the vastness, eventually circles back to something personal. About you. About the soft, temporary body sitting in front of this screen, listening, wondering. Because underneath every theory, every telescope, every machine, is a mind trying to outrun something death. We rarely admit it, but our hunger for knowledge, our obsession with time, our need to leave something behind, it all points in the same direction. We are the only creatures, as far as we know, that fully understand we're going to end, and we don't accept it. So we imagine other timelines. We theorize about uploading consciousness. We ask if the soul can travel through space-time. We wonder if intelligence, once born, can ever truly die. And here's where it gets strange. The same physics that suggests particles can entangle across the galaxy, that time can loop, that information can vanish into silence, also leaves room, just barely, for something beyond finality. Maybe death, like measurement, is not an end. Maybe it's a change in state. Some scientists and thinkers have speculated that consciousness could be a pattern, something that, if copied or transferred, might persist. Others imagine minds running in simulations, a digital afterlife built from code and memory, a dream that never ends because it was never tied to cells in the first place. And then there are the quieter theories. Ones that say, maybe this is the afterlife. Maybe the fact that you're conscious right now means you always will be. Not in this body, but in a body, somewhere. It's not proof, it's not comfort, but it's not nothing. Because physics hasn't ruled it out, and mystery hasn't gone anywhere. If that made you feel the weight of your own breath, and the brief, bright moment of existing, science may not give us eternity, but it gives us the tools to ask whether forever was ever ours to begin with. And maybe the desire to live forever isn't about escaping death, but about finally understanding life. The universe is expanding every second. Galaxies drift farther apart. Space itself stretches quietly, relentlessly. And as it does, the stars grow dimmer, the sky emptier, the night colder. It won't happen tomorrow, or in a million years. But someday, the lights will go out. The last stars will burn through their fuel. The last black holes will evaporate. Matter will decay, and what's left won't be silence, but stillness, absolute stillness. No warmth, no motion, no thought, just cold. This is the long view, the heat death of the universe, a future where entropy wins, where everything useful, everything structured, everything alive, dissolves. But here's the paradox: if it all ends in nothing, then why did anything begin? Why emerge from that stillness only to return? Why produce consciousness only to watch it vanish? Why spend billions of years assembling stars, molecules, minds, for a story that ends with a blank page? Some say the universe doesn't care. It has no reason, no plan. It simply is. Others wonder if this echo, this final stillness, is part of something larger. Maybe entropy isn't death. Maybe it's a reset, a coiling spring before another beginning, a deep breath before another big bang. Or maybe this is the only round, and the echo we're hearing isn't from the end. It's from us. Our questions, our hopes, our attempts to write meaning into a system that never asked to be understood. Maybe the echo isn't from the edge of time, but from our own need to matter in a universe that keeps whispering back. You are temporary. Still, we listen. Sometimes. Science doesn't answer the question. It is the question. And maybe the echo at the end of time is the sound of something that once dared to care. We've talked about black holes and time loops, multiverses and information loss, cats that are dead and alive, observers who shape reality, machines that learn to think. But beneath all of it, every contradiction, every mystery, something has been quietly watching you. Not as a bystander, not as a narrator, as the paradox itself. Because here you are, aware, wondering, temporary, infinite. A creature built from dust, asking questions no stone ever asked. You contain atoms that came from stars that died before Earth was born. You think in language that evolved from grunts and firelight. You imagine your own end, and you keep going. That shouldn't be possible. You're built from parts that don't care about you blind molecules, mindless energy, systems that follow rules, not dreams. And yet, somehow, from all of that, you emerged, not just breathing, thinking. And here's the cruel wonder: no matter how far science stretches, no matter how many dimensions we unfold, how many timelines we map, how many equations we balance, the thing we understand least is the one asking the questions. What are you? A signal riding a nervous system, a flash of organized matter, a glitch in biology, or are you the universe's answer to its own silence? We'll never know for sure, because every answer folds back in on itself. Every path loops. Every truth becomes a mirror. You are not outside the mystery. You are inside it. And maybe that's what all of this has been about. Not to solve the paradoxes, but to realize that you are one. A mind that can't explain itself. A being aware of its own disappearance. A voice echoing through a universe that may never reply. And still, you ask, maybe the last paradox isn't out there in space or time. Maybe it's here, now. The impossibility of you. And that's where the story ends. Or maybe where it begins.
In the silent vastness of deep space, where darkness cradles the birth and death of stars, drifts a galaxy unlike any other PGC 1074. From a distance, it appears serene, a luminous ring of pale, uniform stars, suspended like a ripple in the fabric of the cosmos. It is a cosmic artifact, a structure so clean and so precise that it seems to defy the chaotic nature of the universe. It hangs in the void, not as a sprawling, messy spiral or a dense, featureless elliptical, but as a perfect, glowing circle. But a closer examination, a deeper look into its faint light, reveals something far more enigmatic. Unlike most ring galaxies, which are typically defined by a prominent central bulge or a bright, star-filled nucleus, this galaxy lacks a clear core. It is as if its heart has gone missing, or perhaps never existed at all. The very center of this grand structure is a whisper, a faint suggestion of a core where there should be a shout. This central emptiness is not just a physical void, it is a profound and unsettling question written in starlight. PGC 1074 belongs to a rare and mysterious class of galaxies known as Hoag-type objects, or O-type galaxies, named after the astronomer Arthur Hoag, who first described such a structure in 1950. These galaxies are defined by their nearly perfect, detached ring of stars surrounding an isolated, and usually compact, central nucleus. They are among the rarest of all galactic forms, making up less than 0.1% of all observed galaxies. But PGC 1074 is even more peculiar, a true anomaly even within this exclusive club. Not only does it lack the typical bright, compact central nucleus that defines a Hoag-type object, but the ring itself appears unusually detached, giving it the unsettling and almost ethereal appearance of a cosmic donut, floating alone in the vast, empty darkness of intergalactic space. The stars in this outer ring are young, bright, and intensely blue, a clear hallmark of recent and vigorous star formation. However, the origin of this ring, the mechanism that sparked this burst of life in such a perfect circle, remains deeply uncertain. There are no obvious signs of a recent collision, no distorted tidal tails or bridges of stars connecting it to a nearby neighboring galaxy. There seems to be no internal bar structure, a common feature in disk galaxies that can channel gas and trigger ring-like star formation. The usual suspects for the creation of such a dramatic feature are all missing from the scene of the crime. Astronomers believe that ring galaxies are generally the result of a specific kind of galactic collision, a bullseye encounter where a smaller, compact galaxy passes directly through the center of a larger, gas-rich disk galaxy. This cosmic punch sends a powerful, expanding density wave rippling outward through the disk, like the ripple from a stone dropped into a still pond. As this wave travels, it compresses the interstellar gas, triggering a wave of star formation in a luminous, expanding ring. But in the case of PGC 1074, such a dramatic and violent explanation feels incomplete, almost out of character with the galaxy's serene and isolated appearance. There is no visible companion galaxy, no characteristic trail of disturbance in the surrounding space, only the quiet, profound silence of an almost perfect circle against the black. The mystery deepens when considering the remarkable symmetry of the ring. Cosmic collisions, even head-on ones, tend to be messy affairs. They create deformed, asymmetrical structures, offset rings, and warped disks. But the outer ring of PGC 7714 is remarkably uniform, a near-perfect circle with its stars orbiting in a well-ordered, coherent loop. It is as if the galaxy has been sculpted with a divine compass, its form too precise to be the result of a chaotic encounter. Some astronomers propose that this galaxy may have formed its ring a very long time ago, perhaps billions of years in the past, and that any evidence of the initial event, the intruding galaxy, the tidal debris, has long since faded beyond our ability to detect it. In this scenario, the galaxy would be a kind of ancient cosmic scar, so old that it has healed into a state of near-perfect symmetry. Others speculate that a rare internal process, one that does not require an external trigger, could have led to this configuration. Perhaps a burst of gas was expelled from an ancient nucleus long ago, or a secular resonance within the galactic disk slowly and gently herded the gas into a ring over eons, leaving only a ghostly halo of young stars and no visible progenitor. Adding another layer of profound curiosity to this cosmic enigma is the presence of a second, fainter inner ring, subtly distinct from the luminous outer one. This nested, two-tiered structure suggests not a single, isolated event, but a complex history with multiple episodes of activity, possibly separated by billions of years of quiescence. The light from this inner ring is redder, indicating that it is populated by much older stars, while the outer ring is intensely blue and clearly much younger. This creates a stratified timeline of star formation, a history written in color, flowing like cosmic tides throughout galactic epochs. What force can create two distinct rings at two different times, with such different properties, all without a prominent central bulge to guide them? PGC 1714 thus becomes more than just a galaxy. It is an enigma written in starlight, a puzzle that challenges our most fundamental models of how galaxies form and evolve. Its central emptiness is not an absence, but a question. Why is there no clear nucleus? What subtle mechanism preserved such perfect symmetry in a universe defined by chaos? Did this galaxy evolve in complete solitude, or was it sculpted by invisible hands, by gravitational encounters now lost to the deep currents of cosmic time? To study such a baffling anomaly, astronomers turn to the power of multi-wavelength observations, scanning the galaxy in visible ultraviolet and infrared light to piece together its story. The data from these surveys confirmed what the eye had already suggested. The outer ring is a site of intense and recent star formation, a cosmic nursery bursting with young, hot, and massive stars, likely less than 130 million years old. These are the ephemeral, brilliant blue giants that burn through their fuel quickly and die young in spectacular supernova explosions. In stark contrast, the inner region, not a traditional dense bulge, but a faint, diffuse, rounded core, hosts a much older, redder population of stars, possibly up to 5.5 billion years old. These are the long-lived, cooler stars that give ancient galaxies their characteristic reddish glow. This stark age difference between the two components confirms that the galaxy did not form in a single, continuous process. Its history is told in at least two distinct chapters, separated by a long period of quiet evolution. The outer ring, so recent and so bright, may have arisen after a late, quiet arrival of cold, pristine gas, which then fueled a new generation of stars in a perfect circle around the aging galactic heart. But where could this fresh gas have come from? In such an isolated corner of the universe, one compelling hypothesis suggests that PGC 1714 may have slowly and gently accreted it from its surroundings, from the tenuous filamentous web of intergalactic gas that stretches between galaxies like a cosmic spiderweb. Over vast periods of time, this primordial material, mostly hydrogen, may have spiraled inward, attracted by the galaxy's gravitational pull, and eventually coalesced into a stable, rotating ring. The density of this newly acquired gas would have eventually reached a critical threshold, triggering a synchronized burst of star formation without the need for a violent collision. If this is true, the galaxy becomes a kind of cosmic oasis, a self-sustaining system slowly gathering nourishment from the void to ignite new life, all while preserving its serene symmetry and its profound isolation. There is also the possibility of an ancient merger, one that occurred so long ago that its visible scars have long since faded. Perhaps billions of years ago, a smaller, gas-rich galaxy collided head-on with what would become the core of PGC 1714. This initial violent event could have triggered the formation of the first inner ring of stars, while also disrupting and expelling much of the interstellar gas into a large, surrounding halo. Over the eons, gravity would have worked its slow magic, smoothing out the chaos of the initial collision, allowing the stellar orbits to settle into a more ordered, symmetrical state. Meanwhile, the gas that was thrown out during the merger may have slowly cooled and rained back down onto the galaxy, settling into a new, stable disk far from the center. After billions of years of calm, this newly settled gas could have formed the second outer ring that we see today, a delayed consequence of a cosmic violence that has long since been forgotten by the stars. However, each of these explanations feels like a story with missing pages, a narrative that does not quite fit all the observed facts. No single existing model can fully and elegantly account for all the peculiar features of PGC 714. Why is the outer ring so clean and free of the distortions and asymmetries that are the hallmarks of galactic interactions? Why is there no residual bar or inner spiral structure, features that are so common in ring galaxies that are thought to be formed by internal processes? Why are the two rings so profoundly different in age and color, yet so harmoniously and perfectly aligned? These are not just questions for astronomers, they are questions about the very nature of cosmic evolution. Galaxies like PGC 1714 offer us precious glimpses into the deep, non-linear, and often surprising pathways of galactic evolution. They challenge our neat and tidy categories of spiral or elliptical, young or old, dynamic or passive. They exist at the very edge of our understanding, inviting us to rethink how galaxies can grow, how they interact with their environment, and how they preserve the memory of their own history. Perhaps the most striking and evocative aspect of PGC 1714 is not its central emptiness, but its profound sense of equilibrium, a cosmic yin and yang of youth and age, of silence and light, of chaos long extinguished, and a strange, quiet order left behind. In a universe that is so often defined by turbulent mergers, collapsing clouds, and spinning, chaotic spiral arms, the quiet perfection of PGC 1017 feels like a deliberate and profound anomaly. It stands alone, not just in the space it occupies, but in the conceptual space of our theories. It is a floating ring with no obvious sculptor in sight, a perfect crime with no suspects. And perhaps that is what makes it so deeply captivating, not what we know about it, but everything we do not yet know. It is a mystery that invites us not to solve it, but to simply be with it, to contemplate its silent, glowing form and the deep questions it raises about the universe and our place within it. The location of the galaxy in the cosmos only adds to its mystique. It is not part of a densely populated galaxy cluster, where gravitational chaos reigns and frequent interactions are the norm. It exists in relative isolation, in a quiet, under-dense region of the universe, far from the violent galactic arenas where ring structures are typically forged. This solitude, this cosmic loneliness, suggests a slow, almost meditative evolution, a process sculpted not by catastrophic collisions with other galaxies, but by more subtle, more elusive, and perhaps more internal forces. It is possible that it is precisely this isolation that has allowed the galaxy's unique and delicate form to persist so immaculately for so long, with no galactic neighbors to disturb its structure, no tidal turbulence to perturb the orderly dance of its stars. PGC 1014 may have been afforded the rare cosmic luxury of stillness, a chance to evolve on its own terms, undisturbed by the noise of the universe around it. This quiet environment, however, raises a profound paradox. If the galaxy is so undisturbed, so free from external influences, how did such a vibrant and youthful ring of stars arise? Star formation is not a passive process. It requires raw material, vast clouds of cold gas and dust, and some form of catalyst to ignite it. In most galaxies, this catalyst comes from the gravitational compression of gas in spiral arms, or from the violent shocks and turbulence generated by galactic mergers. But PGC 1714 shows no spiral arms and no signs of a recent disturbance. The usual suspects for triggering a starburst are all absent. And yet, the stars of the outer ring still shine, intensely blue and defiantly bold, as if they were born from nothing but the pure geometry of the void. There is something haunting about this silent creation, something that speaks to a deeper, less understood mode of galactic life. PGC 1714 challenges our understanding not just of galactic mechanics, but of the very nature of cosmic time, memory, and transformation. In its serene and perfect form, we see the faint echoes of an event that may have once happened, a drama whose actors have long since left the stage, or perhaps an event that never occurred at all in the way we understand it. It is a shape without an apparent cause, a ring without a finger, a wave without a splash. It is a powerful reminder that in the vast and complex history of the cosmos, not every structure is a direct and violent consequence of another. Some forms may be the result of waiting, of slow, invisible processes peeling away layers of chaos over the eons, of a gradual settling into a state of profound and beautiful equilibrium. The absence of a central bulge, the missing heart of the galaxy, becomes a symbol in itself, a resonant silence at the core of the galaxy's being. Most galaxies, like our own Milky Way, hold the bulk of their mass at their center, condensing stars, gas, and a supermassive black hole into a dense, bright, and active heart. But PGC 1714 does the opposite. It expresses itself at its edges. Its life, its vibrancy, its beauty, lives not in its center but in the symmetry of its circumference. It is a galaxy that speaks through absence, through what it holds back rather than what it displays. It is a cosmic minimalist, a structure of profound elegance and restraint. And in that sense, PGC 1714 becomes more than just a peculiar astronomical object. It becomes a question mark inscribed in stars, a structure that resists our attempts at categorization, that defies the neat molds of galactic classification, that whispers of a cosmic order we have not yet grasped. It is at once primitive in its simple, circular form and incredibly refined in its symmetry and balance. It is ancient at its core and newly born at its edge. It is mechanical in its orbital precision and almost mystical in its appearance. It is galaxies like PGC 1714 that serve as crucial reminders that the universe is not simply a system of predictable laws, but also a rich and varied landscape of exceptions. For every model we build, For every formula we write to predict the motion of stars or the growth of galactic disks, there exists a PGC 1007 quietly and elegantly invalidating our certainty with its silent defiance. Its luminous blue ring is not just a loop of incandescent stars. It is a loop in our logic, a beautiful circle drawn around an explanation that we have not yet found. And yet, it is this very mystery that fuels the scientific imagination and drives our quest for understanding. With every puzzling detail, PGC 07 becomes a natural laboratory for the exploration of new and unconventional theories. Could its unique structure be the result of interactions not with another galaxy, but with the invisible and mysterious dark matter that we know surrounds it? Perhaps unseen substructures within its dark matter, halo filaments or clumps of this unseen mass, have gravitationally guided the collapse of intergalactic gas into a perfect ring, acting as an invisible mold for the visible matter. Or perhaps PGC 1071 is an ancient relic of a different population of galaxies that may have been more common in the early universe, long before the dominance of spirals and ellipticals. It could be a fossilized blueprint of a lost evolutionary path, a survivor from a different cosmic era. Some theorists have even entertained the possibility that its perfect symmetry is an illusion, a trick of the light caused by a rare and precise gravitational lensing event, where the light from a more distant normal galaxy is bent by an intervening massive object into a perfect circle, an Einstein ring. But none of these scenarios, as intriguing as they are, fully captures the strange and serene equilibrium that this galaxy presents: a perfectly proportioned circle, suspended in a profound and lonely solitude, ancient at its core and blooming with new life at its edges. To observe PGC 1007 is to witness a moment of galactic stillness, not a frozen, static moment, but an expectant one, a structure caught mid-thought in the long, unfolding sentence of cosmic time. We may never know the full story of what shaped it, but perhaps the lack of easy answers is not a flaw in the observation. It is an essential part of the experience. This galaxy does not invite us to solve it as a problem, but to inhabit it as a mystery, to orbit its deep silence as its stars do, to consider the profound possibility that some of the most beautiful structures in the universe are not made to be explained, but simply to evoke a sense of wonder. In the end, PGC 1007 is not just a cosmic anomaly, it is a meditation. It is a meditation on form without apparent force, on balance without external pressure, on the rare and precious stillness of a system that does not demand to be understood, only to be witnessed. Amid the constant violence and chaos of galactic dynamics, it is a ring of peace, serene, symmetric, and deeply, profoundly beautiful. And so, PGC 1007 continues its slow, graceful rotation in the dark depths of the southern sky, far from our own galaxy and farther still from our easy comprehension. It does not command our attention with bright, violent outbursts or dramatic interactions. Instead, it persists in a state of quiet, almost regal, elegance, a lone ripple frozen on the surface of space-time. Each stately orbit of its luminous ring is a soft echo of a hidden cosmic history, a luminous question, tracing the very limits of what we think we know. It is a powerful reminder that the universe is not built solely on the typical, the average, the predictable, but is also shaped by the rare, the silent, the anomalous, the elegant irregularities, the whispered exceptions to the rules. PGC 1007 tells us that not all galaxies grow through the chaotic beauty of spiral arms or collapse into the dense, featureless glow of elliptical cores. Some choose to trace their stories along the edge of the void, in the profound symmetry of isolation, in the quiet grace of a ring with no origin we can name. And perhaps that is the truest and most important lesson it has to offer us, that beauty in the cosmos is not always tied to function, that order can arise from silence, and that mystery is not a flaw in our knowledge to be solved, but a space in our understanding to be respected. PGC 10714 does not explain itself, and perhaps it does not need to. It simply is. A luminous enigma drifting at the edge of our understanding, glowing softly, patiently in the dark. In the endless, sprawling ocean of galaxies that populate the observable universe, the chaotic spirals tangled with star-forming arms, the giant ellipticals swollen with ancient red light, and the irregulars scattered like the cosmic debris of ancient collisions, PGC 10714 stands out as a singular, almost contemplative presence. It does not shout for attention with the brilliant glare of a quasar or the violent light of a supernova. It murmurs, its form as subtle and as perfect as a ripple left on a still pond by an unknown event. It moves with a timeless, stately rhythm, an elegant relic of a cosmic process we do not yet understand. And in that profound stillness lies a strange and powerful kind of eloquence. Its circular outer ring, almost mathematical in its precision, glows with the intense, vibrant light of young, hot, blue stars, massive, ephemeral suns burning through their brief and brilliant lives on the very edge of the void. They orbit not a bustling, crowded galactic nucleus, but an ambiguous, quiet, and almost absent center. No elegant spiral arms reach out to gather matter. No dense central sun funnels gas into a cataclysmic starburst. Instead, PGC 10714 embodies a rare and beautiful equilibrium, a system where the outward expression is far more vivid and alive than the inner heart. It is a cosmic architecture that seems to invert the usual logic of galactic evolution, where activity and mass normally collapse inward over time. Here, for reasons we do not yet comprehend, creation has bloomed outward, as if the cosmos decided to paint this particular canvas from the center out, leaving the middle almost untouched. Telescopic observations across the electromagnetic spectrum reveal that the outer ring of PGC 10714 extends almost 130,000 light-years across, a diameter slightly larger than that of our own Milky Way. It is composed of intensely luminous clusters of stars that are remarkably young in astronomical terms, having formed in a synchronized burst of creation. This suggests that the formation of the ring was not a random or staggered process, but the result of a coherent and organized event that swept through the galaxy's outer regions. Yet the lack of visible instigators, no nearby interacting galaxies, no gaseous bridges connecting it to its environment, no obvious debris from a past merger, means that the ultimate cause of this creative event remains deeply, profoundly veiled. Even the inner region of the galaxy, though faint and less structured, tells its own compelling story. Photometric analysis of its light reveals a diffuse, reddish structure, a clear sign of an aging population of stars housed in a spheroidal, almost spherical, distribution. There are subtle hints of a former, now faded ring, or perhaps a fossilized disk, a suggestion that PGC 10714 may have once been a more typical galaxy, a galaxy with a more defined center, perhaps even with spiral arms that have since been lost or transformed into the serene structure we see today. The idea that we are witnessing a single static moment within a much longer and more complex metamorphosis is not just compelling, it is haunting, like a perfectly preserved shell found on a cosmic beach. PGC 10714 may be what remains after eons of silent, invisible tides have washed away the evidence of its past. In many ways, this galaxy acts as a kind of astronomical koan, a paradoxical question or statement that is used in Zen Buddhism to provoke doubt and test a student's progress. It is an unanswerable question designed not to be solved with logic, but to be contemplated until a deeper understanding arises. It exists at the intersection of our neat categories. It is ring-like, but not like the typical collisionally formed rings we are familiar with. It is highly symmetric, but not clearly sculpted by any known gravitational hand. It is isolated from the chaos of the universe, but it is still actively evolving. It is the embodiment of a contradiction, and yet it holds together with such elegance and precision that those contradictions feel deliberate, as if the universe created it specifically to defy our explanations, to remind us of the profound limits of our current models. What does it mean for a galaxy's most prominent and beautiful feature to be its emptiness at the core? What does it tell us about the myriad pathways of cosmic evolution that such a high degree of beauty and coherence can arise without a clear precedent or a visible consequence? PGC 1014 is not just a structure in space. It is a moment in time, a lone, elegant sentence in the epic, ongoing story of galactic history. It may represent a rare and transient phase, a transitional body passing through a state of being that we are only just beginning to recognize. Or it may be a survivor from a long-lost population of galaxies, a living ghost of a galactic species that once thrived in the early universe and now flickers alone on the quiet margins of our vision. Perhaps what makes PGC 1714 so profoundly and enduringly captivating is not just its strange and beautiful structure, but the deep and quiet feeling it evokes, the way it silently demands our attention, like a cosmic artifact too symmetric to ignore and too inexplicable to dismiss. In a universe so often defined by the sound and fury of its most violent processes, by collisions, explosions, ejections, jets, and chaotic spirals, this galaxy offers a powerful and serene counterpoint. It is a whisper in a cosmic storm, a perfect and ordered form where we would expect to find disorder, a ring without a story that we can yet tell. Astronomers have pointed out that even within the incredibly rare class of Hogue-type or O-type galaxies, PGC 1714 is a true and singular anomaly. Hogue's object itself, the iconic and eponymous ring galaxy discovered in the mid-20th century, at least has a dense, bright, spherical nucleus of old, yellow stars anchoring its structure. PGC 1714 does not even have that. Its core is faint, featureless, diffuse, and unassuming, as if the galaxy is deliberately trying to erase its own origin, offering only a minimalist, ghostly sketch of a center where most galaxies would wear a brilliant and heavy crown of mass and activity. It is like stepping into a vast, ancient cathedral and finding the altar missing, and yet the architecture still holds. The silence still speaks with a profound resonance. That central emptiness is not just physically void, it is emotionally and philosophically evocative. It creates a kind of gravitational metaphor. We, the observers, are drawn in by what is not there, much like we infer the presence of black holes by the matter and light that disappears into them. The deep mystery of PGC 1714 lies in its absence, in the tantalizing possibility that something fundamental to its galactic identity has been removed, hidden, or perhaps never even existed in the first place. And then there is the symmetry. In nature, on Earth, and in the cosmos, perfect symmetry is rare, and where it exists, it is often fragile and ephemeral. Perfect snowflakes melt, bubbles burst, and even the most symmetrical living organisms have their slight deviations. Yet this galaxy's outer ring maintains a calm, disciplined, and almost mathematical equilibrium, curving without any noticeable distortion, enclosing a vast region of space in a near-perfect circle. It is hard not to see it as something deliberate, something almost artistic, as if nature itself paused its usual chaotic brushstrokes to draw a single, clean, and perfect line before returning to the messy business of creating the rest of the universe. To imagine how such a structure could have formed is to enter the realm of speculative astrophysics, a place where our models must bend and the data whispers more than it declares. Could it be that PGC 17714 formed not from a direct and violent collision, but from a more subtle and gentle event, the slow, patient accretion of cold, pristine intergalactic gas, forming an annular starburst at just the right distance from a faint and ancient core? Could subtle gravitational resonances, rarely observed and even more rarely sustained over billions of years, have sculpted its stars into place, like a celestial standing wave, a pattern of cosmic music made visible? Or perhaps its perfection is, itself, just a phase, a rare and fleeting moment between more turbulent and chaotic epochs, a galaxy caught in an instant of transformation that will never look quite the same again, like the calm, quiet eye of a hurricane, or the frozen, perfect ring of ripples around a stone that was dropped into a pond long ago. PGC 17714 may be suspended in a state of temporary, beautiful serenity before the inexorable forces of entropy and gravitational dynamics return, and its delicate structure begins to unravel into something more common, more disordered, whatever the cause. This galaxy has become more than just a case study for astronomers. It has become a symbol of cosmic patience, of improbable order, of a form of evolution that is not driven by violence, but perhaps by stillness. And in that role, PGC 17714 transcends its celestial coordinates and its dry, technical classification. It is no longer just a galaxy. It is a mirror held up to the cosmos, reflecting not just starlight, but the profound depth and hunger of our own curiosity. Let us now delve deeper into the poetic architecture of the cosmos, where an object like PGC 17714 no longer belongs just to the realm of science, but also to the philosophy of the night sky. In a universe that is governed by the inexorable arrow of time and the second law of thermodynamics, where everything tends toward disorder and chaos, PGC 17714 seems to momentarily and beautifully pause that inevitable fall. It is an act of perfect balance in a sea of cosmic imbalance, a geometric and elegant negation of the universe's inherent tendency towards entropy. It holds itself together like a memory that refuses to fade, delicate, quiet, but unmistakably, profoundly present. Time may move around it, stars may be born and die within its luminous orbit, but the perfect ring remains, turning slowly and silently around a center that offers no clear explanation for its own existence. And perhaps that is its deepest secret. It embodies the concept of memory, but not the kind of memory that we can easily archive or understand, not the kind that is found in data or images alone. PGC 10714 is a memory without a narrator, a structure left behind by an event whose witnesses are long gone, whose ultimate cause is lost to the deep past, and whose consequences are still gracefully unfolding before our eyes. It is the silent, visual echo of a song that we cannot hear, preserved for us only in the ancient language of light. In this way, this distant galaxy becomes a powerful metaphor for much more than just astronomy. It becomes a meditation on the nature of identity itself, both galactic and human. Who are we when we no longer remember how we came to be? What remains of a structure when its very core has been removed or has faded into obscurity? Can a form exist without a clear function? And can beauty exist without an obvious purpose? PGC 17714 seems to answer these profound questions, not with words or with data, but with its simple, elegant, and undeniable presence. It simply is. We, the observers, orbit it not with spacecraft and probes, but with our thoughts and our imagination. Our telescopes, extensions of our own curious eyes, capture its faint and ancient photons, particles of light that have been traveling across the void for hundreds of millions of years to reach us, light that left the ring long before we walked the earth, before the first mammals arose, before the continents on our own planet had drifted into their current shapes. And yet, that ancient light arrives now, perfectly on time, to our waiting instruments and to our hungry imagination. We behold it from across the vast, dark gulf of space-time, and in doing so, we participate in a cosmic act of recognition, a meeting of minds across an almost unimaginable abyss. This silent, distant galaxy reminds us that not all of the universe's truths shout. Some are written in the silence between the stars. Some are drawn in the darkness of the void. Some galaxies burn with the brilliant, violent activity of their cores, birthing stars by the billions and tearing apart their cosmic companions in fits of gravitational fury. But PGC 1714 does none of that. It does not burn with a fierce fire. It glows with a soft, cool light. It does not speak in a loud voice. It endures in a quiet whisper. And perhaps that is its final and most profound message for us, that not everything in the universe is urgent, that some things, like this pale, perfect, and lonely ring, are meant to be noticed slowly, understood only partially, and remembered fully, not just for what they are, but for the sense of wonder they inspire. Let us let the mystery of this galaxy linger a moment longer, not in an attempt to solve it, but simply to honor it. Because perhaps PGC 1714 is not meant to be deciphered like a complex mathematical equation, but to be experienced like a profound and beautiful poem. Its luminous ring, glowing faintly in the deep abyss of space, becomes a single, perfect stanza, written for us in the ink of starlight. Each of those brilliant blue stars is a syllable in a language far older than humanity, older than the Earth itself, older even than the familiar, grand spiral galaxies that dominate our night sky. To look at it is to briefly and humbly touch the immense patience of cosmic time. It is not an answer to our questions, but a pause, a cosmic breath held in the deep, silent lungs of the universe. And that quiet pause invites us, in turn, to stop our own frantic search for answers, to listen to the silence, and simply to wonder. In our relentless rush to measure, to model, and to categorize, PGC 1714 gently whispers, stillness. In our deep-seated hunger to classify and to label, it offers a form that slips through the fingers of our taxonomies like light through empty space. And in the constant, deafening noise of a universe that is expanding without end, it speaks of something incredibly rare and precious: completeness without chaos, form without apparent force, and existence without the need for an explanation. Somewhere within the dark and silent cathedral of the cosmos, where the distant galaxies flicker like the light of 1,000 stained glass windows, in the vast, profound hush of intergalactic space, drifts a perfect ring of light, a structure of both burning creation and ancient memory. PGC 1714, no name, no classification, could ever fully capture what it is. Not fully. Not really. It is more of a symbol than an object, more of a question than an answer. It is like a wound in space-time that has healed into a perfect, glowing circle, and the longer you gaze upon it, the more it begins to feel like the universe itself is trying to say something to us, not with force, not with clarity, but with a quiet and profound grace. Because this galaxy is not chaotic. It does not unfold its stars in arms thrown wide like dancers in ecstatic motion. It does not roar with powerful jets of matter or burn with the intense heat of colliding galactic giants. It is calm, it is perfect, it is measured. It is a single luminous ring, glowing against the deep and velvet dark, as if a god had drawn a circle in the night with a single glowing fingertip, and then, without a trace, disappeared. That ring, so impossible and so beautiful in its symmetry, is made of young, intensely blue, brilliant stars, newborns in cosmic terms, burning hard and fast and destined to live short lives. But unlike most ring galaxies, there is no majestic, bustling center, no crowded and luminous galactic nucleus to draw the stars inward with its immense gravity. Instead, there is only a faint, diffuse glow at its core, a whisper of a memory long after the voice that spoke it has gone silent. The eye, trained by observing thousands of other galaxies, expects to find a heart, but in this galaxy, the heart is missing. Or perhaps it is just hidden from our view. This central paradox, this emptiness at its core, is what gives PGC 1714 its profound and mysterious power. It is not just strange, it is quietly, elegantly strange. It does not baffle our senses with violence and chaos. It seduces our minds with its silence and its order. It is the kind of mystery that does not announce itself with a loud bang. You have to notice it. You have to be still long enough for the deep and quiet question to emerge from the darkness. How could such a perfect and lonely form ever arise? We know that rings in galaxies often mean collisions, dramatic, head-on crashes where one galaxy punches through the very heart of another, sending powerful ripples of compressed gas and dust through its stellar body, a process that ignites a wave of new star formation in a brilliant, expanding ring. But here, in the case of PGC 1714, we find no debris, no gaseous bridges, no second galaxy, no cosmic smoking gun. There is just this, a newborn circle of burning light, wrapped around an ageless, almost centerless core, suspended in the void, untouched, whole, and profoundly alone. And if it was not formed in a moment of cosmic violence, some theorists have suggested that this beautiful ring may have formed gently, through the slow and patient accretion of cold, pristine gas from the intergalactic medium, that vast, invisible sea of hydrogen that lies between the galaxies. Over hundreds of millions of years, that primordial gas could have gathered and cooled, slowly spinning up to form the stable, star-forming ring that we see today, a structure cradled by the invisible hands of dark matter and sculpted by the pure mathematics of symmetry. In this peaceful vision, PGC 1714 is not a cosmic scar, it is a cosmic flower, a rare and beautiful blossom blooming in the near-perfect vacuum of intergalactic space. But even that elegant explanation does not fully explain everything we see, because PGC 1714 does not have just one ring, it has two. The inner ring, fainter, older, and redder in color, is like a ghostly, silent echo of the brilliant and youthful outer one. This layered, nested structure suggests an even deeper and more complex mystery, not one moment of creation, but two. Not a single isolated event, but a long and complex sequence. As if this galaxy has somehow managed to reinvent itself through the deep river of cosmic time. As if in its profound loneliness, it has learned to sing in multiple, harmonious voices, a brilliant blue for its youth, a soft red for its age, a perfect harmony in its form. We do not know what it is becoming. We barely know what it is. But we do know this, it is rare, impossibly, beautifully rare. Among the hundreds of billions of galaxies that we have observed, only a handful display this kind of coreless, double-ringed symmetry, and fewer still are so profoundly isolated, so completely free of any outside interference. In a cosmos that is so often governed by the brutal laws of gravitational wars, this galaxy seems to have chosen a path of peace, and yet there is a profound tension in that peace, a beauty that is born not of ease, but of a quiet and powerful endurance. Because to remain so untouched, so perfect, in a violent universe is itself a monumental feat. It suggests a hidden strength, a quiet resilience, a way of being in the universe that we are perhaps only just beginning to understand. PGC 1014 is not just a galactic curiosity. It is a cosmic koan. It is compact, it is resonant, and it is almost infinite in its implication. It reminds us that even in the coldest and most desolate voids of space, wonder can bloom. That not all of the universe's stories are told with loud explosions and violent collisions. Some are traced in silent, perfect circles. Some only speak when we take the time to listen to the quiet. And some are still gracefully and mysteriously unfolding. And perhaps we, from our small blue world, drifting under the light of our own star, were meant to witness this strange and beautiful galaxy, to record its light, to wonder at its form, to remember its existence, not just as scientists seeking answers, but as a small piece of conscious matter, briefly awake in a vast and silent universe, looking out across the abyss of time at a perfect and enigmatic mirror made of stars. To understand the unique structure and complex history of PGC 1714, astronomers must rely on a careful and multifaceted approach, combining detailed photometry, which is the measurement of the brightness and color of its light, with spectral energy distributions, which break that light down into its constituent wavelengths, and sophisticated dynamical modeling, which attempts to simulate its motion under the laws of gravity. What makes this particular galaxy so profoundly fascinating to scientists is that it challenges several of our fundamental and most cherished ideas about how ring galaxies form, evolve, and are maintained over cosmic timescales. Traditionally, ring galaxies are associated with violent and specific gravitational interactions, typically a head-on, bullseye collision where a smaller, compact galaxy passes directly through the disk of a larger one. This dramatic process generates powerful radial density waves, like the ripples spreading from a stone dropped into a still pond. These waves travel outward through the larger galaxy's disk, compressing its reserves of gas and dust, and triggering a massive, synchronized burst of star formation in an expanding, luminous ring. But in the case of PGC 1714, we see none of the telltale signs of such a catastrophe. There is no visible intruder galaxy in its vicinity, no faint streams of stars torn from the interacting galaxies, no warped or distorted disk, no tidal tails. The ring is too clean, too quiet, too perfect. The observational data we have gathered so far suggests that a much more subtle and delicate process might be at play in the formation of this remarkable object. A strong and leading candidate is a process known as cold mode accretion, the slow, gentle, and continuous inflow of pristine hydrogen gas from the vast and tenuous intergalactic medium. In the cold, dark voids between the galaxies, primordial hydrogen, left over from the Big Bang, flows along immense, invisible filaments of dark matter, forming the cosmic web. If a galaxy is isolated and gravitationally stable, like PGC 1740 appears to be, this intergalactic gas can slowly settle into orbit around it, cooling and condensing over hundreds of millions of years. Eventually, this accreted gas could form a stable, rotating ring, and when its density reaches a critical point, it could ignite a wave of new star formation. This scenario could elegantly explain the young, intensely blue stars of the galaxy's outer ring, all of which appear to have formed relatively recently. Astronomers estimate their age to be within the last 130 million years. Meanwhile, the faint inner region of the galaxy tells a much older and quieter story. Photometric analysis of its light reveals a diffuse, reddish structure, a clear sign of an aged stellar population. with stars that are likely more than 5.5 billion years old. This stark contrast in age and color between the inner and outer rings is extremely rare and provides strong evidence that PGC 1714 went through at least two distinct and well-separated evolutionary phases, a long, passive, and ancient history, followed by a recent and dramatic rejuvenation at its edges. This kind of double-ring structure invites other, more complex theories, particularly those involving orbital resonances. These are specific radii within a galactic disk, where the orbital periods of the stars and gas are in a simple integer ratio with the rotation of some large-scale pattern, like a central bar. These resonances can cause gas and dust to accumulate at those specific locations, leading to the formation of rings. In typical spiral galaxies, a central bar acts as a powerful dynamical engine that can funnel gas toward the center of the galaxy, triggering starbursts, or can create ring-like structures at its resonance points. But in PGC 1714, there is no visible central bar. If one ever existed, it must have long since dissolved, leaving only its faint, ghostly gravitational fingerprints behind in the form of these two rings. Another crucial factor in maintaining the pristine symmetry of this galaxy is likely the nature of its dark matter halo. All galaxies are thought to be embedded in massive halos of this invisible dark matter, which govern their large-scale gravitational behavior. In the case of PGC 714, a perfectly spherical, or at least highly axisymmetric dark matter halo could act as a stabilizing force, preserving the ring's orderly, circular motion and preventing it from warping or fragmenting over cosmic time. This would also help to explain the striking absence of the asymmetric distortions and tidal features that are so typical in collisionally formed ring galaxies. High-resolution spectroscopy could shed much more light on this enduring mystery. By creating a detailed map of the rotational velocities of the stars and gas within the ring, astronomers could determine if its motion is purely circular, which would support a quiescent formation model, or if it contains traces of elliptical or radial motion, which would be a telltale sign of a past gravitational disturbance. So far, such detailed data is limited due to the galaxy's great distance and its intrinsic faintness. But future instruments like the Extremely Large Telescope and other next-generation infrared observatories could provide the necessary precision to resolve these subtle motions. There is also a rich chemical story hidden in the galaxy's light. If we could resolve the metallicity gradient across the galaxy, that is, the abundance of elements heavier than hydrogen and helium, we could learn how chemically enriched the star-forming gas was. A low metallicity in the outer ring would be strong evidence for the cold gas accretion theory, suggesting that the gas is pristine and has come from the intergalactic medium. In contrast, a higher metallicity might point to internal recycling processes, or to the reaccretion of gas that was ejected from the galaxy in a much earlier epoch. Taken together, all these lines of evidence present PGC 714 not just as a beautiful rarity, but as a true and unique cosmic laboratory, an exceptional case study in the long-term evolution of a galaxy in a state of profound isolation, far from the disruptive influence of major cosmic structures. It challenges our standard understanding of how galaxies can evolve and whether stable and dramatic ring structures can form without the need for violent collisions. And that fundamental question has implications that go far beyond this one single strange object. It speaks to the true diversity of galactic forms and evolutionary pathways that are possible throughout the vast expanse of cosmic time. PGC 1714 is not just visually unusual, it is a profound astrophysical anomaly that rigorously tests our most fundamental models of galaxy formation and evolution. Its near-perfect, luminous outer ring of young blue stars combined with its faint, older central region that completely lacks a defined, bright bulge, places it firmly outside our standard classification systems for galaxies. It does not resemble a familiar spiral with its chaotic and beautiful arms. It lacks the dense, featureless, and often overwhelming core of a typical elliptical galaxy, and it shows none of the telltale chaotic signs, the warps, the tails, the bridges, that are normally associated with the aftermath of galactic collisions. And yet, against all odds, it exists serene, symmetric, stable, and glowing with a quiet internal light. Multi-wavelength observations, from the high-energy ultraviolet to the cool infrared, have allowed us to piece together a complex and fascinating stellar history for this object. The outer ring is populated by hot, massive, and short-lived stars, suggesting a recent and powerful burst of star formation, an event that likely took place within the last 130 million years. In stark contrast, the diffuse reddish core hosts a much older population of stars, with an estimated age of over 5.5 billion years. This dramatic duality implies a two-phase formation process, a long, quiet, ancient epoch, followed by a sudden and spectacular rejuvenation at its outer edges. But where did the vast reservoir of gas needed to fuel this new generation of stars come from? The usual explanation for the formation of ring galaxies involves head-on collisions that generate powerful density waves, compressing the interstellar gas into star-forming rings. But, as we have seen, PGC 1074 shows none of the typical and expected residuals, no tidal tails, no structural disturbances, no nearby companion galaxy that would point to such a violent encounter. Its profound isolation in the cosmos reinforces the idea that it must have had a more subtle and gentle origin, perhaps through the slow and patient accretion of cold, pristine gas from the intergalactic medium. In this peaceful scenario, the galaxy would have slowly gathered primordial hydrogen over hundreds of millions of years, cooling it and settling it into a stable, rotating disk. The conditions within this new disk would then have been just right to ignite a synchronized ring of new stars at a specific, stable radius. That radius might be governed by fundamental stability thresholds, such as the Tumra-Q parameter, a measure that determines when a rotating, self-gravitating disk of gas will become unstable and collapse to form stars. The presence of two distinct and concentric rings adds another and even deeper layer of complexity to this already profound puzzle. The inner ring appears to be much older and redder, while the outer ring is brilliantly young and blue. This may indicate the occurrence of multiple distinct gas accretion events, separated by billions of years of cosmic time, or perhaps it is the result of complex resonance phenomena within the galactic disk that have shaped the gas into rings at different times. It is possible that the galaxy once had a weak central bar, a very common feature in disk galaxies, which has since dissolved and faded from view, leaving behind only its gravitational imprints in the form of these concentric ring structures. To distinguish between these possibilities, we would need to map the kinematics of the system in great detail, to see how the stars and the gas are moving, whether the two rings rotate in the same direction, whether their motion is perfectly circular or shows signs of elliptical distortion, and whether there are any subtle signs of internal torques or non-circular motions that would hint at a more complex history. Unfortunately, such detailed spectroscopic data is still scarce. Due to the galaxy's extreme faintness and great distance, future observations with the next generation of more powerful instruments could, and likely will, fill in these crucial gaps, providing us with precise velocity fields and detailed metallicity profiles. If the chemical abundance, or metallicity, of the outer ring is found to be very low, it would be strong support for the cold flow accretion theory, suggesting that the gas is pristine and has not been enriched by previous generations of stars. If, on the other hand, the metallicity is found to be high, it could point to more complex internal processes, or the reaccretion of ancient, enriched gas that was expelled from the galaxy long ago. Either result would fundamentally reshape our view of how galaxies can evolve in a state of profound isolation. Far from the violent and crowded environments of galaxy clusters, dark matter also likely plays a crucial and stabilizing role in this story. The clean, undisturbed, and perfect symmetry of the outer ring implies a very well-balanced and smooth gravitational potential. If the galaxy is embedded in a smooth, spherical dark matter halo, this would help to preserve the ring's delicate structure over immense periods of time, minimizing any distortions. If that dark matter halo were triaxial or clumpy, we would expect to see signs of warping or instability in the ring. The fact that we do not see such features suggests that the galaxy sits in an unusually harmonic and peaceful gravitational environment. Statistically, galaxies like PGC 1714 are extremely rare, Hoag-type or O-type. Galaxies make up less than 0.1% of all known galactic systems, and those with double rings and no bright, defined nucleus are rarer still. But it is precisely in these strange and beautiful edge cases, these outliers, that science often makes its greatest leaps forward. They act as natural and unique experiments, testing the absolute limits of our current models and reminding us, with a profound humility, that not all galaxies follow the same expected evolutionary path. In this sense, PGC 1714 is more than just an anomaly. It is a window into the possible, a glimpse of what can happen when time, gravity, and gas meet in a state of perfect and perhaps temporary stillness. Its profound silence is an essential part of its message. In a universe where galaxies are so often formed and shaped through violence, through chaotic mergers, through the tidal stripping of their stars, through cataclysmic collisions, PGC 1714 seems to have grown with a profound and otherworldly patience. There is no evidence of close companions, no intergalactic debris fields, no long, drawn-out tidal arms or stellar streams that would betray a recent or ongoing interaction. It is surrounded by a vast and quiet emptiness, and yet its form is so precise, so ordered, that it demands an explanation beyond the ordinary. This very isolation may, in fact, be the key to its long-term survival and its pristine form, with no galactic neighbors to disturb it, no gravitational harassment from some surrounding systems to disrupt its delicate balance. It has been able to preserve a kind of galactic purity, an architectural clarity that would be almost impossible to maintain in the denser and more violent environments of galaxy clusters. If we could use a cosmic time machine to fast forward to its distant future, it is unclear what path it would follow. Will the beautiful blue outer ring persist for billions of years, slowly fading from a brilliant blue to a dim red as its stars age and die, eventually leaving behind only a faint, ghostly halo of ancient light? Or will new, pristine gas accrete onto the galaxy once again, giving rise to a third generation of stars, perhaps forming yet another, even more exterior ring? That remarkable possibility would turn PGC 1714 into a kind of stratified, living time capsule, a galactic tree ring recording each distinct era of its creative activity in ever-expanding circles of luminous light. Its structure would then be a visual history not of destruction and chaos, but of quiet, cyclical rebirth through the patient accumulation of matter from the void. Studying this strange and beautiful galaxy could also shed new light on the nature of the very early universe. If the slow and gentle accretion of gas from the cosmic filaments can produce such dramatic and ordered ring-like star formation in isolated environments, then perhaps such galaxies were much more common in the distant past. When cold, pristine gas was far more abundant, and the rate of galactic mergers was lower in certain quiet regions of the cosmos. In that sense, PGC 714 might not be merely a modern-day rarity, but a living fossil, a contemporary representative of a galactic formation mode that is now all but extinct, save for a few exceptional and lonely survivors like this one. It could be a blueprint for a lost and forgotten evolutionary path for galaxies. It could also have profound philosophical implications for how we define and categorize a galaxy. Most of our definitions are based on a galaxy's morphology, its mass or its stellar population. But PGC 1714 seems to resist all of our simple labels. It has no spiral pattern, no central bulge, no active nucleus. And yet, it is an organized and coherent system, a self-contained gravitational and stellar entity with its own long and complex history. Perhaps it demonstrates that the boundaries we draw between ellipticals, spirals, lenticulars, and rings are not as fixed and as meaningful as we believe. Maybe the form of a galaxy is more fluid and more transient in the deep river of cosmic time than any of our static classification systems can ever hope to capture. The more we study galaxies like this, the more we are reminded that cosmic evolution is not a single linear story. It is a branching, cyclical, and often recursive process, where profound symmetry can arise from deep silence, and where breathtaking beauty can emerge from the very absence of chaos. PGC 1714 is a living contradiction, a galaxy that should not be so pristine, and yet it is. A ring of brilliant young stars that should be unstable, and yet it persists. A structure that should reveal the cause of its own creation, and yet it keeps its deepest secrets hidden. It invites our observation, but it does not offer easy conclusions. It invites our most profound questions, but it offers no simple answers. And in doing so, it becomes more than just an object of scientific study. It becomes a phenomenon to be experienced, a cosmic structure that, like the universe itself, offers more than we can ever hope to measure and far, far more than we can yet understand. Instruments like the James Webb Space Telescope and the future ground-based Extremely Large Telescope offer us unprecedented new opportunities to decipher the silent and beautiful enigma of PGC 714. With their extraordinary infrared sensitivity and their ability to resolve incredibly fine spectral features, they can peer deeper into the heart of this galaxy's structure than ever before. The Webb telescope, in particular, with its ability to see through the obscuring veils of cosmic dust, can map the stellar populations and the dust content in both the outer and the inner rings with incredible precision. It can reveal whether the younger stars of the outer ring formed in a gas-rich, dusty molecular environment or from more pristine, metal-poor material. If Webb's sensitive instruments detect subtle gradients in the emission from polycyclic aromatic hydrocarbons, which are complex organic molecules, or from warm dust, it could confirm the presence of faint but active star formation that was undetectable in previous, less sensitive surveys. It could also provide precise constraints on the metallicity of the gas in the rings, a chemical fingerprint that could unlock the secret of the ring's origin. A flat and low metallicity profile across the outer ring would be a strong indicator of the smooth accretion of cold, primordial gas from the external environment. A radial gradient in metallicity, on the other hand, would suggest a more complex history of internal recycling of enriched gas from previous generations of stars. Meanwhile, the ELT and other planned 30-meter class ground-based observatories will make it possible to study the kinematics of the individual stars and gas clouds within the ring, measuring the velocity field with high precision at thousands of different points. This would allow us to answer fundamental questions about the galaxy's dynamics, whether the ring rotates like a solid, rigid body, whether it shows signs of radial expansion or contraction, or whether it follows a more complex and subtle orbital configuration. Such detailed data would allow us to build much more accurate models of not only how the ring may have formed, but also how it has managed to remain so remarkably stable over hundreds of millions of years. Another exciting possibility is the detection of faint hydrogen gas structures in the vast space around the galaxy, using the next generation of powerful radio observatories, such as the Square Kilometre Array. If extended, faint hydrogen tails, filaments, or inflow streams are detected in the galaxy's immediate vicinity. It would offer direct smoking gun evidence of intergalactic gas feeding the galaxy, a clear confirmation of the source of the fuel for its ring of fire. These structures, if they exist, would be far too faint and diffuse for previous radio surveys to have detected, but modern instruments with deep integration times could reveal them in exquisite and game-changing detail. PGC 1014 could also become a template, a kind of astronomical archetype, for identifying similar systems at high redshift in the early universe, a time when cold gas was much more abundant and the universe was more conducive to smooth accretion rather than chaotic mergers. By using the deep field capabilities of the James Webb Space Telescope to search for other coreless, companionless ring galaxies in the early universe, astronomers might be able to uncover a whole hidden population of proto-O-type systems, the young, formative versions of what PGC 1714 represents today in its mature and evolved state. Such a discovery could fundamentally change the way we think about the life cycles of galaxies. While the dominant narrative of galaxy evolution has long focused on the idea of hierarchical mergers and violent structural transformations, galaxies like PGC 1714 suggest that alternative, more peaceful evolutionary paths might exist, paths that are shaped not by collision and chaos, but by slow, patient accumulation, by subtle internal resonances, and by the profound peace of a quiet cosmic environment. These paths may be rare in the universe today, but in the ancient cosmos, they could have played a crucial and previously unrecognized role in forming the rich diversity of galactic structures that we now observe. In this sense, PGC 1714 is more than just a beautiful curiosity. It is a potential cosmological Rosetta Stone, a key that could help us to unlock the secrets of these quiet formation processes that often go unnoticed in the face of more dramatic and violent galactic events. If we can learn to read the language of its rings, its perfect symmetry, its complex chemistry, its subtle motion, we may discover a hidden grammar of galactic construction, a set of rules that operates outside our usual understanding. And while all of this scientific inquiry happens, the galaxy itself continues to drift, turning slowly and silently in a quiet corner of the cosmos, its ancient light still arriving at our world after crossing hundreds of millions of years of empty space. Each of those photons is a message from the deep past, a tiny fragment of a grand and beautiful story that we are only just beginning to comprehend. The faint light that we receive from PGC 1714 is a time capsule, a stream of ancient photons that began their immense journey long before human civilization existed, long before the continents of our own Earth took their present shapes, long before our own species even emerged from the plains of Africa. Every single piece of data that we gather from this distant object is a fragment of a history that has already been written in the language of stellar motion, of chemical gradients, and of a profound and mysterious gravitational equilibrium. And yet, it is only now, in in this brief moment of our own existence, that we are learning to read that ancient and beautiful history. One of the most fascinating frontiers in the study of that history lies in the idea of galactic memory, the profound notion that a galaxy's present-day structure, its morphology, its kinematics, and its chemistry encodes the entirety of its long and complex history. In most galaxies, like our own spiral galaxy, that memory is often chaotic, overwritten, and scrambled by a long history of mergers, warps, and violent starbursts. But in an object as pristine and as ordered as PGC 1074, with the clarity of its rings, the smoothness of its core, and the stark contrast between its stellar populations, it seems more like a perfectly preserved fossil, a clean, clear, stratigraphic record of cosmic time, written for us in the elegant script of light. If our most sophisticated cosmological simulations could manage to recreate such a unique and beautiful structure, not just visually, but dynamically and chemically, they could help us to isolate the precise and rare initial conditions that make such an object possible. Large-scale cosmological simulations like Illustris, Eagle, and TNG-50 attempt to model billions of years of galactic evolution under the standard model of cosmology, which includes dark matter and dark energy. However, extremely rare and pristine ring galaxies, like PGC 1074, very seldom appear in these simulations in such a perfect form. This suggests either that the specific initial conditions required to form such a galaxy are so exceptionally rare that they are not captured in the simulated volumes, or, more intriguingly, that our current models of galaxy formation are missing some crucial and subtle physical processes, perhaps the effects of low angular momentum, gas flows, or non-merger-driven instabilities, or the complex interplay of feedback-regulated accretion over giga-year timescales. Perhaps what PGC 1714 truly represents is a kind of transitional state, a galaxy caught in a moment of transformation that is so slow, so stable, and so graceful that we are only able to detect it by looking deep into the past. It may not always have been a ring galaxy, it may not always be one. But in this particular phase of its long life, with its sharply defined outer structure and its ancient, diffuse inner core, it represents a unique window into a state of profound galactic equilibrium, a state where internal forces, angular momentum, and a quiet external environment have all converged to produce a moment of near-perfect and beautiful balance. That delicate balance may not last forever. The brilliant, young, blue stars in the outer ring are massive and short-lived. They will age quickly, and over the next few 100 million years, they will one by one explode as spectacular supernovae, leaving behind a graveyard of neutron stars and black holes, and enriching the surrounding interstellar medium with heavy elements. If no new pristine gas arrives to reignite the process of star formation, the brilliant blue ring will slowly fade, its vibrant light giving way to a dimmer, redder glow as its remaining. Smaller stars grow old. Over billions of years, the elegant ring structure itself could dissolve, its stars slowly dispersing due to subtle gravitational interactions, eventually leaving behind only a diffuse and ghostly halo of ancient stars, a faint memory of the perfect form it once had. In this sense, we may be witnessing a fleeting moment of supreme galactic beauty, a delicate and transient structure that exists only in a brief and quiet interlude between a forgotten past chaos and a slow, inevitable future oblivion. This transience, however, does not diminish the galaxy's deep mystery. It only deepens it. It reminds us that the universe is not a static museum of unchanging objects, but a dynamic and ever-evolving landscape of complex and beautiful processes. The galaxy PGC 1074 becomes, then, something more than just an object of scientific study. It becomes a profound lesson in cosmic perspective. It teaches us that to truly understand the cosmos, we must look not only at the violent, the chaotic, and the dramatic events, but also at the quiet, the ordered, and the long-lived. It teaches us that absence can be just as informative and as meaningful as presence, and that the emergence of perfect symmetry in a universe that is fundamentally chaotic is one of the most profound and beautiful statements that nature can ever make. And it teaches us that, despite our most powerful telescopes and our most sophisticated models, the universe always reserves the right to surprise us, to present us with a perfect, glowing ring in the middle of the darkness for no apparent reason other than that it can